2, 1. So permutation of n objects under repetition of items. I want to talk about two things, and I'll do it through examples and then show you kind of the generalization as well. Now this is the easier case when you have repetition. I'm going to do another video with regards to repetition, but now again we'll have n objects, but we're not going to be permutating. We're not going to be trying to find out the order of all n. We're going to pick, our reserved ones from them. So I'll do that video. I'll put up a link up above there. I'll do it through an example once it's done. So n objects under repetition of items. Okay, so for the first case which you will run into is if you consider an example like this. You wanted to be able to count how many permutations, so how many different orders are there. And someone says that they give you, okay, and say they give you the digit 1, 2, 3, 4, and 5. And they ask you, all right, assuming that you can repeat the digits, how many different digits would you be able to create? So how many different permutations would you have if you wanted to make 3-digit numbers? Okay, so going back to things that you have done already in terms of organized counting, when you're utilizing the multiplicative principle, for example, and if we're going to be allowed to repeat, okay, these particular digits, then we know that in the first spot we can put 5 different digits, all of these. In the second spot we can also pick all of them because they can repeat. And in the third spot, again, we would pick all of them. So now by the multiplicative result, we're going to get 5 to the 3, which in this case would have been 125 different types, okay, of permutations, just different numbers in general. All right, so that's the first thing that we do is when you are allowed to repeat something, okay? So that's that case. Now, in general, if you have n objects, doesn't matter if they're digits or not, any n objects, and you're allowed to repeat them, then depending on how many of those n you're going to be choosing, okay, let's say maybe instead of 3, you're going to have a certain amount. Okay, I'm going to put ... all right, and I'm going to say there are m of these, right? So you're going to have m different spots to put these into. So then we would take n objects, so this would be n. Again, we could repeat, so it can be n again, and n again, and n, and so on for every single one. So you will find that what we have is we have n, right, of them to choose from. And how many times? Well, m times. So our exponent would have been m. So our general formula is n to the m if we're allowed to repeat the objects. Now, that's the first case, and you could have picked any characters, any objects, anything you wanted. So that's the first example of repetition. The second example of repetition is a little bit different. It's harder a touch, but it also yields a very nice formula for us. So let's imagine I will have, again, let's say maybe this time around, I'll have an A, and let's say, I don't know, maybe a C. So I have AAC. And out of these 3, now notice these 2, okay, are repeated. This one is not. And I would ask you, okay, so I have 3 different characters. And again, it can be 3 different objects. And I would ask you, okay, so how many permutations do you have now, okay, that still carry, 3 characters? So it is the same amount. So I have 3 characters in my set, So if I made this a set, so I have 3 of them. And I'm wondering, okay, in how many different ways can I order these around? Now, if we didn't have the A repeated 2 times, then it would have been pretty simple, right? You will remember that by permutations, so if I, for instance, had A, B, and C, then by permutations, this would have been just 3 factorial. Or, we could write it as 3 because we have 3 items, okay, and we're permutating them, okay, and we're reserving 3 of them. So it's 3p3 or just 3 factorial, which is exactly the same thing. Now, because of the fact that we're now repeating one of the characters, it won't be 3 factorial anymore because the A and the A will be indistinguishable. Now, of course, if we didn't have this distinguishing factor, if we call this, A1 and we call this A2 where we were differentiating them, then we would be back to this example where the A's are actually different. Now, I just want to show you what will happen, and I'm going to do it by brute force first. So really I would have, okay, so A1, okay, so that would have been 1, A2, and then I would have had a C. Again, so if I started with A1, I could have swapped the 2, so C and then the A2. So that could have been another permutation that I would have. There are actually no other that are starting with this A1. So now I would go to, let's say, A2, and then I would pick A1, C, A2, and then C and A1. And then finally, I could start with my C, and then I would have A1, A2, C, A2 and A1, which is my 3 factorial, which is basically 6 permutations that I would have. But if I remove, and I don't know that there's a difference between the ones that are repeating, then all of a sudden, I can see that I do have repetitions here. So notice AAC, AAC again here. So that's one of them that repeated. I would have, so here's another one, so ACA, and then ACA again. That has been repeated. And then lastly, of course, you can tell that I have CAA and CAA also repeated. So in reality, so out of these, I really just have 3 different permutations, which is clearly not 3 factorial. So how would I be doing this? Would I just by brute force start doing it like this? You can if you have not a lot of characters or not a lot of objects, but if the objects are growing, even if it gets to 5, 6, 7, and so on, and you have some repeated objects that you can use, then it's going to be a little bit of a pain. Well, there is a formula when we do run into this. And the way that we do it is, we assume that they are distinct. Okay, so we have, now in this case, we had 3 factorial. So we're going to say, all right, what if we had 3 factorial? But now we're going to be dividing it, and we're going to be dividing it by the character that repeats. Now, in our case, the repeated one was the A and the A. So that's what I had here. So really, there was no difference, okay, between, these two. There was no difference between these two and no difference between these two. Because the A1 and the A2 could have been swapped, right? And in how many different ways can I swap them, right? Because there's only 2 of them. Well, 2 factorial. So I would divide this by 2 factorial, which is the character, which is the A character, and how many times does this one repeat? Well, it repeats 2 times, so we will put in here and divide by that 2 factorial. And you can try that and continue it. So in general, if we had n objects, and inside of these n objects, I had some objects that repeated multiple times. So let's say that maybe one of the objects, okay, was repeating and I'm going to use, let's say, for repeating R. Okay, so this object repeated R one times. Now, could have been 2, 3, 4, okay? Now, you had another set of objects that repeated, but maybe the same or different amounts, but they were different objects, but they also repeated. So you would have R2. And you can find all of the ones that repeated and how many times did they repeat. Okay, so this would have been to some, let's say, R, M. I don't know how many of them were. And I'm going to give you another example to illustrate this. And the general formula is that you take the overall n factorial, which is all the permutations, assuming that they never repeated, and then you would divide by how many times each of those objects repeated. So if this object repeated R1 times, you would divide by R1 factorial, and then you would divide by R2 factorial, and so on. Okay, so you would do this to each one that repeated. So to illustrate this particular concept, so let's say what I would have is the following. So let's imagine that now I had, say maybe A, okay, B, another A, C, okay, D, another A, maybe another B, and then maybe another D. Okay, so let's say these were my objects. They don't have to be letters. They could be numbers, they could be colors, could be marbles, they could be people, anything. All right? So in this particular situation, what I would have is, I have a total of 1, 2, 3, 4, 5, 6, 7, 8. So my N is 8 objects in total. Now, I will say, okay, my first object that repeated, so in this case, I'll actually be specific. So how many times did the A repeat? So instead of putting a 1, okay, right here, I'll put RA, okay, because I'm just talking about the A. How many times did that repeat? Well, it repeated 3 times. Then I'll take a look at the B. The B actually repeated 2 times. And then there's no other, oh, I'm sorry, the D. The D also repeated 2 times. So to find the total number of permutations, this formula will do the trick for you. So instead of arranging them, you can simply say, okay, how many in total permutations? Well, n factorial. Or, of course, you can write this as n Pn, because we're choosing all of them. And now, what would we do is, well, this one is going to be able to be swapped around 3 factorial times. This one, 2 factorial, and this one, 2 factorial. So what we would have is, we would have 8 factorial divided by 3 factorial multiplied by 2 factorial multiplied by 2 factorial to get our answer, and whatever that answer would be. And of course, we can compute this now, right? We can get what the answer to this is, either by using a calculator or by dividing. I'll leave that for you to be able to do, because I don't think that that is a huge step for you. Okay, then you can put it down in the comment to see if you will match any other person who's going to try to see what that answer would be. But that's how you approach if you wanted to know how many permutations you would have with repeated items or objects within your entire list. Now, we made an assumption here that we're always are going to be arranging them into the total number. So if we had 8 objects, we're asking how many different 8 object permutations are there? All right. Now, that is the easy part because we have a beautiful formula for that. But, okay, in the video that I linked in the beginning of this video, the harder question is, what if we did have something like this, but instead of asking how many permutations of the entire 8 objects, What if I wanted to only take all of the objects, but I wanted to see how many permutations of maybe 4 of them I would have, or 3, or 2 for that matter? And that question I will answer in that other video. You can find the link, okay, at the beginning of this video. That's what I was referring to. So instead of picking all 8, what if we just picked and said how many 4-letter permutations are there from our set of these 8 characters? And that, unfortunately, is not that easy. And I'll try to show you with some simpler examples. Okay, we'll see you in that video. Bye, everybody. I hope this helped. Cheers.